Soon we're going to discuss how to find angles and side lengths of triangles that are not right triangles, but before we do that, we'll need some information about the inverse cosine function. So let's learn a little bit about the inverse cosine function, then we'll discuss how to use it. So the inverse cosine function, we use the notation of cosine to the -1. And although we write to the -1, remember we pronounce this as cosine inverse. Just like when we talked about inverse functions, the notation was f inverse of something. We wrote to the -1, but we say f inverse. So cosine inverse of something equals theta, and we can write what this means in terms of the original function cosine by simply switching the inputs and outputs. So this would mean that x equals cosine theta, and we do need to be a bit specific here that theta is between 0 and 180 degrees or 0 and pi radians. We'll see later that this is due to making a domain restriction on the cosine function, but don't worry about the details on that for now. What you should know is if you do cosine inverse of some number, let's say 0.15, then the output theta will be an angle between 0 and 180 degrees. So theta is an angle between 0 and 180 degrees, so 0 less than or equal to theta, and very technically this is a strictly less than 180 degrees. Again, don't worry about too much about these details, just know that cosine inverse of 0.15 is going to give you an angle theta between 0 and 180 degrees such that 0.15 equals cosine theta. Now every calculator, at least every scientific calculator, is going to have an inverse cosine button, and I'm going to use that right now in order to figure out what cosine inverse of 0.15 is. Now I have my calculator in degree mode here, so I get a degree answer for this angle, and what I would get is 81.373 degrees. And so what this is telling me is that this 81.373 degrees is an angle between 0 and 180 such that cosine of that angle is 0.15. And we could go ahead and check this by taking 81.373 degrees and putting it into the cosine function. And if I do that, then I evaluate cosine of 81.373 degrees, and I get that this is equal to 0.15 and then 0.0001. So up to some round off error, this is in fact true. And so you can use these inverse cosine functions to solve what are called some trigonometric equations. And this is what's going to be useful for us. Then what I can do is I can use the inverse cosine function, do cosine inverse of 0.15, and then the output will be an angle theta. It will be between 0 and 180 degrees, and it will be such that cosine of that angle is 0.15. So my answer would be cosine inverse of 0.15, which is 81.373 degrees. Again, when you do these in your calculator, make sure that your calculator is in the appropriate mode. When you do cosine inverse of a number, the output is an angle, and it's going to be angle that's measured in whatever mode your calculator is in. So if your calculator is in degree mode, then your answer is going to be in degrees, and if it's in radian mode, it will be in radians. Now let's use this fact to find angles in a right triangle. Notice that this is a right triangle with a right angle. Later we'll see how to adapt this solution so that we can find angles in triangles that are not right. But for now, we have this right triangle, and it's given that One side is 12 and the hypotenuse is 13. And I want to know what is this angle. And what I'm going to do is I'm going to use the trigonometric function that relates my angle with the two sides that I know. So in this case, I know the sides adjacent and hypotenuse. And so cosine is the trigonometric function which has the adjacent side or the adjacent leg and the hypotenuse. So cosine of this angle theta is 12 over 13. And also note that theta has to be between 0 and 180 degrees because the sum of all angles has to be 180 degrees, so theta itself could not be bigger than 180 degrees. It's actually even more restricted because we know that one of the angles of this triangle is a right angle that's 90 degrees. So that actually means that theta has to be even smaller. It has to be between 0 and 90 degrees. But in any case, I only need to know that the angle is between 0 and 180 degrees in order to use the inverse cosine function. So if cosine theta is 12 over 13, then if I use the inverse cosine function, then this will give me an angle between 0 and 180 degrees such that cosine of this angle will be 12 over 13. So I have my calculator in in degree mode here, and so my solution is going to be 22.620, simply typing in cosine inverse of 12 over 13 into my calculator. There's a lot of details we'll see about how to use the inverse cosine function later when we talk about the inverse trigonometric functions, but for now, this understanding will be sufficient. That is, whenever you need to solve cosine theta equals a number, and you know that theta is between 0 and 180 degrees, you can get your answers by using the inverse cosine function.